Okay, so imagine this. It's the middle of the night, it's pitch black outside,
Yeah.
and you flip a switch.
But it's not a light in your house.
No, not at all. Suddenly, a 5-kilometer patch of ground outside is just bathed in sunlight. Real, actual sunshine.
Beamed down from space. Yeah, that's the pitch from a startup called Reflect Orbital. They call it sunlight as a service.
Which sounds completely wild.
Yeah.
The idea is to use these huge mirrors in orbit to reflect the sun onto solar farms after dark.
Right, to basically just delete the whole concept of night for the renewable energy grid.
So today we're going to dig into this. We've got a bunch of studies here, and we need to figure out if this is a real revolution or if it's just, very shiny sci-fi hype.
And the first thing you find when you look into it is that this is not a new idea. Not at all.
I was so surprised by that. I just assumed this was some brand new out there tech.
No, it goes back almost a century. To 1923, a physicist named Hermann Oberth. He was already imagining these massive space mirrors.
But he had a slightly more aggressive name for them, right?
He did. He called them sun guns. He thought they could be used for, climate engineering or even as weapons.
Yeah, sun guns definitely sounds a bit less friendly than sunlight as a service. Did anyone ever actually try to build one?
Oh, yeah. The Soviets gave it a real go in the 90s with a project called Znamya, which means banner.
Okay.
And in 1993, they actually deployed one, Znamya 2. It was basically a 20-meter wide sheet of, space tinfoil.
It worked. They managed to unroll this thing in space.
They did. They spun it out from a spacecraft and flashed a beam of light about 5 kilometers wide all across Europe. People on the ground saw a pulse of light as bright as a full moon.
Wow. But I'm guessing there's a catch.
There is. When they tried again with the next version, Znamya 2.5, the foil ripped on an antenna while it was deploying.
So space origami is... It's risky. These things are incredibly fragile.
They call them gossamer structures, and that's the big engineering hurdle. But, even if they solve the folding problem, there's a much, much bigger issue.
The physics.
The physics. Reflect Orbital claims they can deliver 200 watts per square meter to the ground, enough to generate real electricity.
And that number isn't realistic.
No, with a single mirror, no. There's this fundamental principle in optics called the conservation of étendue.
Okay, what does that mean in simple terms?
Think of it like a flashlight. Up close, the circle of light is small and bright. But if you shine it from way across a field, that light spreads out, it gets dim.
Because the sun isn't a laser pointer, the light is always going to diverge.
It has to. And the math on this is brutal. From an orbit of 600 kilometers, that beam of light must spread to at least 5.5 kilometers wide.
So what does that do to the brightness?
It means a single, huge, 54-meter mirror would only deliver about 0.13 watts per square meter.
0.13. They need 200. That's useless for a solar panel, isn't it?
It is. It's basically bright moonlight. Solar panels have a threshold. They need a certain intensity just to wake up. At 0.13 watts, they produce zero electricity.
So how could this ever work then?
You'd need something called superposition.
Which means you stack the beam.
You stack the beams. You'd need something like 1,500 satellites, all of them in orbit, all pointing at the exact same patch of ground at the exact same time to get the brightness up to 200 watts.
1,500 satellites.
Yeah.
Just for one solar farm. That sounds, wouldn't it be cheaper to just buy a battery?
And that's exactly where the economics just completely fall apart. Right now, storing power in a big lithium-ion battery costs maybe $130 per kilowatt hour.
Yeah.
It's getting cheaper every day.
Right.
To get that same power from space, you're talking about a constellation that costs nearly $1 billion to launch. The math just doesn't work for bulk energy.
So if the energy math is that bad, why are people even investing in this? There has to be another angle.
I think there is. They might not be selling power. They might be selling illumination.
Selling light itself.
Exactly. Think about a disaster zone where the grid is down, or search and rescue missions at night, or even, entertainment. They have this phrase, Friday night satellites.
Lighting up a football stadium from orbit instead of using floodlights.
You'd pay a premium for that.
But wait, that brings up a huge issue we haven't touched on. If you're lighting up a stadium from space,
you're also lighting up everything else around it. Yeah, that's the regulatory nightmare.
astronomers must be absolutely horrified by this.
They are, because with something like Starlink, they at least try to paint the satellites black to make them less visible. But here...
the whole point is to be a giant mirror. You can't hide it. It's creating light pollution by definition.
it's basically graffiti on the night sky. And you have to wonder what the legal case is here. You're lighting up the atmosphere for everyone, not just the solar farm.
So it really makes you think, as we get this power, to literally commercialize the night sky, you have to ask a bigger question.
Mm-hmm.
Who actually owns the darkness?
Mm.
And is a slightly longer day really worth losing the stars?
That is the question to sleep on.